Hey everyone, and welcome. Today we are going to pull back the curtain on the invisible magic that makes our entire digital world, well, work. We're talking about communication protocols, the secret language that everything on the internet speaks.
I mean, have you ever really stopped to think about it? Your phone, your laptop, your smartwatch, maybe even your refrigerator, they're all made by different companies, yet they connect and share information like it's no big deal. How does this happen? What stops the internet from just being a total, chaotic mess? Well, the secret is all about a shared set of rules.
And that's the core idea right there. Our communication protocol is really just a set of rules. You can think of it like grammar for computers. It makes sure that when one device sends a message, the other device knows exactly how to receive it and, more importantly, how to understand it. They are, quite literally, the backbone of our connected world.
Okay, to really wrap our heads around this, let's build something in our minds. Let's imagine the entire system of internet protocols as one massive digital skyscraper. Each floor has a totally different job to do, but they all have to work together perfectly to get information from the very top floor all the way down to the street and across the city to another building.
So here's our tour of this skyscraper. We're going to start at the very foundation, where local connections are made. Then we'll check out the street grid for global navigation. After that, we'll see how the delivery service gets all our data right. Then it's up to the penthouse to see the application protocols. And finally, we'll see how the whole skyscraper gets assembled.
All right, first stop, the ground floor, the very foundation of our building. This is what's known as the data link layer, and it's all about making those initial local connections.
Think of this layer as the actual concrete and steel of our building, the physical stuff. We're talking about the radio waves from your Wi-Fi router or the physical cable you plug into your computer. It handles the direct connection between devices that are right there in the same room or the same building. It's the absolute first link in the chain.
And you know what? You use these protocols every single day. Ethernet, that's your classic network cable. Wi-Fi, of course, is the wireless standard we all know and love. And yep, even our cell phone connections, from 2G all the way up to 5G, operate right here on this fundamental layer, connecting your phone to the nearest cell tower. Okay, let's head up a floor to the network layer. We've got our local connections sorted, but now we need a way to navigate the entire globe.
This is where every single device connected to the internet gets its own unique address. We call this an IP, or Internet Protocol Address. It works just like a postal address for a building. It's the system that lets a little packet of data from your computer in, say, New York, find its way perfectly to a server located in Tokyo. Now, the original addressing system was called IPv4, and using its 32-bit system, it gave us about 4.3 billion unique addresses. Back in the day, that sounded like an impossibly huge number. But with the explosion of phones, computers, and smart devices, we started running out, and fast.
And this is where the solution comes in. IPv6. It's the latest version, and instead of 32-bit addresses, it uses 128-bit ones. Now, the number of unique addresses this creates is just mind-boggling. It's more than enough for every single grain of sand on every beach on Earth to have its own unique IP address, with trillions left over. The takeaway here is, our digital city now has plenty of room to grow.
Okay, so our data packet has a global address, but how does it get from the building's mailroom up to the right person in the right office on the right floor? Well, that's the job of the transport layer.
And on this floor, we basically have two main delivery services. On one hand, you've got TCP. Think of this as your certified sign-on delivery courier. It's meticulous. It checks that every single piece of your data arrives in the right order with no errors. It's perfect for loading a web page or sending an email where every detail has to be perfect. Then, on the other hand, you have UDP. This is more like just dropping a letter in the mailbox. It's ridiculously fast, but it doesn't double-check anything. It's perfect for things like video calls or online gaming, where you'd rather have top speed, even if it means a tiny little glitch here and there.
And that brings us all the way to the top of our skyscraper, the penthouse. This is the application layer, and it's where all that data actually becomes useful to us, the users.
See, up here in the penthouse, every single suite is a different app. Your web browser, your email, your smart thermostat. And each of these applications uses its own specific protocol, a highly specialized language just to do its one particular job. Let's look at a few of the most important ones.
First up, the big one we all use constantly, HTTP. This is the fundamental language of the web. It's a really simple conversation, really. Your browser sends a request saying, hey, can I see this website? And the server responds by sending it back. That simple back and forth is what powers basically all of our web browsing.
Now for something totally different, MQTT. This is a language designed for machines to talk to other machines, especially for the Internet of Things.
Its genius is how incredibly efficient it is. See, instead of a tiny sensor constantly asking a server, anything new, anything new, anything new, it just waits. A central broker tells the sensor only when there's an update. This saves a massive amount of battery life.
And in that same vein, we have CoAP. As the name suggests, it's built for constrained devices. We're talking hardware with very little memory and very little power. CoAP is the protocol that lets a tiny, dirt-cheap temperature sensor out in a farm field use the exact same internet as a supercomputer, but by using just a tiny, tiny fraction of the resources. And finally, let's talk WebSockets. Remember how HTTP is that simple request and response conversation? Well, WebSockets completely change the game. They open up a persistent, two-way communication channel. This means the server can push information to you the instant it's available, without you even having to ask. This is the magic behind live chat apps, real-time online games, and those stock tickers that update right before your eyes.
So, we've toured every floor of our digital skyscraper. Now, let's put it all together and watch it in action. Let's follow one little piece of data on its incredible journey.
It all starts at the top. Your web browser, up in the application layer, creates a request for a website. That data then travels down to the transport layer, which wraps it up in a nice, reliable TCP package. Then, the network layer stamps that package with the correct global IPv6 address. And finally, it hits the foundation, the data link layer, which shoots it out over your local Wi-Fi or Ethernet cable, taking the very first step of its journey across the world.
And that quote really sums it all up, doesn't it? It doesn't matter if we're talking about the huge, powerful servers that run our favorite websites, or the tiniest little sensors in an IoT system. These protocols, they are the essential, invisible backbone that holds the entire connected world together.
And all of this leaves us with a pretty fascinating question to think about. We've built this absolutely incredible digital skyscraper, right? But it's always under construction. As we connect billions and billions more smart devices, what new challenges are we going to face? And what new protocols, what new floors on our skyscraper are we going to have to invent to meet